Welcome back, everybody. So, still working through the Bootcamp stuff, and just kind of give you, where we're at. We did 17 days at Bootcamp, and so today we are going all the way up, or we'll see how much we cover. But this is week 4 is, day 2 is 17 days. And so we have, what I have not got through yet is 4, 5, 6, 7, and 8. That's it. So we're getting close to the end of getting through all the bootcamp material, which is awesome. And I've put everything into one playlist, Learn to Code Golang Training, 142 videos. So slowly, I guess I'll just leave these up because I have links out there going to these playlists. But if you want one resource for all of the videos, they're all here. So it's just one playlist. And right now they're all listed, day 1, part 1, and we created them sequentially like that so that we could make sure that they're stacked in order. Right? But now that I've got them in order, I'm going to be going back through and changing their names so that the names are a little bit more indicative of what each video is about. And so you can see I've already started to do that here at the end. And this gives you a little bit of an idea of some of the stuff that's there in the end. We had a Google Cloud Storage project, right? And then we did an example with stock data, and we looked at using net HTML to sort of create your own package, and to be able to sort of either do a crawler on web pages, right, and go get all the different DOM elements off of one page and go through them all and pull out all the links and everything like that. And then we did something with charting, Chart.js, and then here we started to do credit cards and Stripe. So that's just a little bit of a high-level overview of where things are at. And I just got an email from someone today at a really cool company up in the Silicon Valley, and they saw my presentation up at Silicon Valley Code Camp. And they're like, hey, you mentioned in your presentation that you know some really good Go guru trainers, and we want to do our next web app with Go on the back end and Angular on the front. Can you get us in touch with those people?
Referral fee. Am I right?
Well, yeah, but well, you know what? If I have the bandwidth, I'm gonna hopefully help them find the people that I think are good, and then see if I could sit in. Just go up and hang out for 5 days or something, and get a little bit of training. But it's kind of cool to be able to contribute, and it's a really awesome company. I don't feel like I'm at I could share who just because I don't know if they want that confidential or not, but anyhow. So let's take a look at some of the stuff for today. And yesterday, or what's today, Thursday, Tuesday, so I went to bed at 6 a.m. So if Daniel, anybody, jump in if I'm saying something incorrectly. But we did App Engine Google Cloud Storage, and then we did the movie website, and we looked at the movie website, and we did some image uploading on the movie website, and then we did the HTTP Giphy web API call, and we did the self-destructing message. And I cleaned up the crypto stuff in here. And so when we were in class, it was kind of I don't know a whole lot about the crypto, but I took some time to sort of let me spend some time with it and get to know it a little bit and break it out into steps. And so here's the first step, just looking at a nonce, a number that's used only once. And then here's the second step where you encrypt it. And so let's just look at that step. And then here's the third step where you decrypt it. And here's the complete. So maybe we'll take a look at that. And then there's also Google Cloud Storage file browser, which is kind of cool. So it'll go to your Google Cloud Storage and then, basically through the web, show you a directory listing of everything that's in there, and shows you how to create folders and go into the folders. There's not actually, in reality, folders in Google Cloud Storage. Everything is a file, but you could create files with slashes in the path names. I don't know if I said that right. Slashes in the names, and those can be parsed to be like folders. Does that make sense? And so that's how you do folders in Google Cloud Storage. So that's a cool folder browser thing. And then Caleb used to work in financial services industry, so there's a couple of financial examples that we already saw I don't know if we saw them in here, but in Bootcamp. And so here's another one where he's just sort of like grabbing data that's financial data, stock market data, and then bringing that down and running covariance. Is that right? No, it was correlation, running correlation against them, which entails also running covariance to calculate correlation. I'm pretty sure I'm no stats guy. But, and then it graphs it out, right, and shows you a graphical representation of the data. And it's a little bit wonky. There's one bug in here, and the one bug is if your data has to match, you basically have two slices of data, and that data has to match. And so the thing to fix the bug, which hasn't been fixed yet, would be to go through and look at each piece of data you get from each company and compare the dates, right? So basically, like, is it still matching? And if one has a date, like if you're asking, give me the closing stock price each day for this for the last 5 years, but one of them for some reason is missing a piece of data, then you just throw that piece out, right? So that'd be the thing to fix it. Otherwise, you get this funny error. So if you run that on your own and you see that funny error, you could change the time frame or change the stock symbols, make it a shorter time frame, and it'll work. And you could go in and try to fix that. And then finally, we have here accepting credit cards and accepting credit cards using Stripe. So I figure we'd start with accepting credit cards using Stripe and just take a look at that, because to me that's like the most valuable out of everything here. Like, if I could only give you one thing, that's the one. So let's start with that, and then we could kind of go backwards and look at some of this other stuff. Sound like a game plan? Cool. I'll stop and take a breath. Anybody have any?
Were you up till 6 in the morning?
Why?
Were you playing Fallout or?
Just dumb, stupid hillbilly drinking. No good reason.
So the Stripe that we're going to be learning about for payment, the GitHub education pack gives you a Stripe code, which makes your first, I think, $1,000 fee-free for Stripe payments.
Cool. I don't see it in there, but right on. There it is.
So yeah,
Oh,
first
that's cool.
no fees for the first $1,000.
Yeah! That's a lot of transactions. Because it's basically like, 30 cents a transaction and 3% or something like that. And so you could do the math on that, but
3 cents plus 3%?
30 cents plus 3, I don't know what, but it's about, merchant banking fees are, 1.8 to 3 cents. But it's competitive with PayPal and other stuff. So how many transactions would that be? That'd be quite a lot. Pretty cool. So let's take a look at Stripe. And just kind of like browse it for a second. And so this is Stripe, and then you could go into documentation. And then inside documentation, one of the places we'll look at is on your website. And on your website, come in here and you could look at this. And here's the code you want to use for test credit cards, right? And any 3-digit CVC and any expiration date in the future. And
Just the future. Not the past.
Yeah. And then, here's just like kind of what you drop in for it to work. It's pretty straightforward, so we'll see this in a second. I'm just showing you where you find that stuff. And then it kind of describes a basic workflow. So here's the whole workflow. And so basically, and I'm not going to say this correctly probably, but I'll get close. Basically, you put this on your page. It provides a checkout. It goes and downloads some JS or something like that. And then that's what that's doing, right? Downloading some more JS.
It's a script tag.
Yeah.
Source that.
And it's kind of different that they put this inside the form, but then that tells it it's connected with that form. But then it downloads that, and then you could do checkout. And when somebody enters their credit card, they take care of all the regulatory stuff. And so there's a bunch of regulatory stuff, which is described somewhere in here. And
For the credit card checking, is that on your site, or do they do that as well?
I think they do that.
Is that
Yeah.
on your own
So
code?
they generate the form.
Yeah. Yeah, they're generating the form, and I believe it talks to their website to
Okay.
try confirming stuff.
It's actually pretty easy. I'll go and do a credit card check.
so they send all the critical data to their server, and they've done all the programming so that all the things that need to happen client side to check happen. and it gets sent to their server, and then they send you back a token, so you're not handling dangerous material on your app, right? And so now you have that token, and it's that token that associates whatever transaction you're processing with the card that already got sent over. And so you get that token back, and then you do the final transaction processing stuff and charge them. And so let's just read through this. The customer arrives at your payment page loaded over HTTPS. So you do need HTTPS. That includes the checkout code. The customer clicks the payment button, completes the payment form, and clicks pay $20 within the checkout window. Checkout sends credit card details directly to Stripe from the customer's browser, assuming the details pass basic validation, right? So from their browser straight to Stripe. Stripe returns a token to checkout or an error message if real validation fails. Checkout takes, so the token comes back to our app. Checkout takes the return token and stores it in the page's primary form, the one surrounding the script tag above, and a hidden element named Stripe token. Checkout submits the form to your server. Your server uses posted token to charge the card. So I said that checkout returns a token to checkout. Checkout's on their page, is that right?
Yeah.
And then this is where checkout submits the
So
form to
basically
your
they're
server.
using an AJAX request to send it to Stripe, and then once the AJAX response is the token number, which it will put into a hidden form element, input type equals hidden, and they'll put the token in there, and then it will submit the form, which goes to your website, and in that way you've got the token.
I like the bit where it gives you the token, no money has been passed you. It just says this is a valid card and you can charge to it.
Mm-hmm.
So it's still up to you to charge.
So it said HTTPS is good. With App Engine, at the beginning of the semester, we said that you can't use HTTPS with App Engine because without using their App Spot stuff or Google Apps, unless you go through like CloudFront or something. They just recently, sometime during this course of the semester, added in HTTPS support for just basic App Engine. So you have to go digging through the, I'm not sure exactly where it was. Yeah, there it is. So under the App Engine tab in their settings, you can put in your SSL certificate and get HTTPS to work on generic App Engine now.
Once again, to get there, you go to App Engine, and then App Engine you go to Settings, and then you go to SSL. Pretty cool. All right, so let's look at some of the basic, some of the examples, and I think the first thing we'll just run it. So change directory 6501, go app serve, and that's going to fire up. And so straightforward app YAML, and that needs to be changed. That's what mine is. Good to check.
I believe there's an app YAML tag you can use to request HTTPS, isn't there?
Probably. I don't know. But it is working without it. It's just test.
Yeah, for the
And
local stuff, yeah.
that's something else that's good to show is when you sign up, right? So if I go to my dashboard, they have this button here, live test. So when you're developing, right, you can totally develop. And here it's test. And my test site is doing really well.
Oh my goodness. What are you still teaching for?
I had one charge yesterday for $200,000
Nice.
at 2 a.m.
Someone in China really likes your work.
No, that was me. All right, so here it is. I've dropped that onto a HTML template page. All right, that's it. And then here I basically said, you know what, parse all my templates. And then at this route, go to handle index. And then here execute the template. So that's it. So just go straight to default. I'll close 8080. Guaranteed investments. Invest with us and get a free box of cookies.
Yes. What kind of cookies?
Pay with card. We take credit cards. So this pops up, and so I put in my test example, and then just that credit card number, and then any thing in the future. So 01 16, and just any number. And then they have a remember me deal that, you know, Stripe can store your payment info, but you got to put in a phone number to verify. And then I pay. That's it.
So it submitted the form, but his only link that grabs everything just serves the template page. So
Yeah, and so we didn't actually process the payment, but it's like, okay, we got that little piece working. So pretty easy, man.
By the
Right.
way, the Stripe page does not require you to sign in. They will give you a test account if you want, which is just like a local 24-hour, I guess, account.
Where does the payments go?
Into my bank. Where do you
So
think they
when
go?
you set it up, you're setting it, linking it, like Stripe to your bank? Or?
Yeah, well, eventually it all flows back into my bank. And they also do payments from you to others. So you could set it up like, oh, I need to pay people.
So
And
it's all set up through Stripe then?
yeah,
Okay.
so you could receive payment from people and you can also send payment to people.
Stripe also supports being the man in the middle for a payment person, for a payment thing. I believe it says that's how Kickstarter uses Stripe.
Oh, I see.
So Kickstarter is just hosting the Stripe and website, and then they're just functioning as the person in the middle between the money flows.
And I put in, yeah,
So what's the advantage of using Stripe over something like
that's a good question. And
Oh,
so
mine probably has,
there's this cool art. Go ahead. Go ahead.
does PayPal also do credit card processing? Oh, I would guess, they've been around forever, they probably do. Yeah, I have a PayPal account, so I'd probably be more likely to go.
Yeah, I would
Right?
be more likely personally to go
Yeah.
something that use PayPal because I already have an account.
Yeah, that's a good point, huh?
After sending 2 50-cent charges to your bank and all that shit you have to go through.
PayPal's gotten bad press in the past, though, if I remember correctly.
They've gotten bad press in the past.
It's for
I
like
think
chargebacks
losing-
and stuff like that.
Losing information, fraudulent charges, stuff like that.
Well, here are the kids who created Stripe. They're in their 20s still. And the company's worth $5 billion. How young are they?
They 16?
Well, they look a little bit like they kind of look a little bit worn, right? But no, they're in their 20s.
I don't know, I can look pretty young if I shave off this developer's beard.
But you know, it talks a little bit in here about, you know, Stripe and how they distinguish themselves from PayPal, and the difference. So that article is right here in the video descriptions. And then I'm just remembering this. I put all these links in. You could do payouts with Stripe, and then here are some documentation examples and the libraries and the Go API docs and getting started on your website. So we'll look at that in a second after we go through the examples.
Yeah, somewhere in the docs they've got other credit card numbers you can use too. The all 42 is like their generic one, but they've also got one for like a couple different credit card types, so you can verify they all work. And then they've got a few ones that will always fail in a specific way. Like there's one that will always approve as being a credit card, but never approve actually paying. So you can test how your website handles those various errors.
But one of the things that stands out about Stripe from what I read is it's very developer friendly. And they've really worked hard to make it super easy for developers to integrate versus other ones. So you could customize the UI on your deal, your checkout. So let's look at that. Ooh. So now I have a minion, and I've customized the deal, and same thing happens. I have no idea who used my computer. Like, that is not me. I don't know why that's coming up. I don't know who that is. Hey, $200,000. Same thing. No other response.
The docs also will describe how to do all that part yourself too if you don't want to use their pop-open window.
Yeah, so you could customize it and create your own pop-up window. And so that's not where that's all the same, but this is where we customized it. Right there, right there, right there, right there. That's customizing it. Control C. Ooh. And so here's starting to get the token and use the token that comes back. And let's see if the template's any different. Template is pretty much the same.
It's the same.
So we now have a /payment and goes to handle payment. And if request method is not equal to post, then method is not allowed. And then Stripe token, we're just getting the value.
So that would be what changed in the form, is it added the where the form
That's right.
action.
So here in the template, we added that,
The
So-
form action.
the form action. So what that looks like, I guess I can just hit that, continue. No, don't like that. And then you'll see that token pop up. I'm not going that way. I don't know, should we show the error? Error because of App Engine. All right, so because we're using App Engine, there's some error that comes up. And so we have the payment, and we get a context, and we get the Stripe token, and then we try to do this function charge account, and charge account comes from something that we wrote. We just stuck it in another file, stripe.go. And so when we try to do charge account, it should give us, I guess, just pass in the token and the context and charge, and let us know if there's an error, and then it'll say, "Thank you for your money, sucker," if it all worked well. And then here, right, we have charge account brings in the token and the context. So where do we use the token? Charge params, or something's charge params, and Stripe charge params, mount, currency, description, and then set source is Stripe token, and then charge new, charge params, and then log info, charge, and then return nil. And so we could look at this stuff, and this is coming from, here we've got stripe.go and stripe.go-go charge. And I'm just looking to see if we're using, there's charge right there, right, for that one. So we got two packages from Stripe that we brought in, and we can look at charge params. And charge params is a set of parameters that can be used when creating or updating a charge. And amount, currency, customer, token, description statement, email. What would that be, destination?
Yeah, I think so.
No capture fee,
The-
fraud,
The
source,
destination
shipping.
is probably for the man-in-the-middle charging. My guess.
And then set source, which takes interface and is method attached to charge params. So we get charge params right here, that's struct, fill it out, and then we have this method set source, and we're putting in the token. So we pass the token in there, adds valid sources to a charge params object, returning an error for unsupported sources. Interesting.
So credit card source. So in case you somehow manage to jury rig your site into accepting 2 credit cards.
You can pass in unlimited. And then charge new. And charge new posts new charges, right? For more details right there, see create charge. So we could dig into that more probably, but. And then log it, and I'm not quite sure what the error is, but
The error is we're not using URL fetch, so when you say charge new.
thank you. Yes, right here. So say more about that.
So App Engine doesn't allow you to just say an HTTP post or something. So when this charge new is going to be actually doing the charge, so it's trying to go with HTTP get or HTTP post or something to Stripe's website, right? On App Engine, you're in a sandbox. You're not allowed to do that. You have to use URL fetch. So we'll get an error on this particular line because App Engine sandbox will block it.
So charge new is trying to pull down some URL resource, URI resource.
Or I think it's posting what we've got so far so it can confirm, I believe.
Why would so the URL fetch, just first of all, that's like if I'm going and getting some URI URL resource, right?
Or posting.
Or
Get
posting,
post.
because that's kind of like a client action, right?
Yeah.
I'm going to have a client, and I'm going to post. And App Engine just, I guess, they want you in that sandbox because they don't want you to turn your App Engine app into some sort of like malicious thing that's just submitting to forms all over the place. Is that the idea? So
Well,
that's,
going through the URL fetch means it's going through their servers handling in the middle, and they can protect against a variety of things like man-in-the-middle attacks and detect
okay.
stuff.
So yeah, let's see it. Let's see it. Go up serve. See what happens. See what the errors we get back. We'll clear this out because we're only looking at whatever it is. I am tired of typing in a credit card number.
It's easy to remember. Well, the expiration date seems to be going up a year every time.
Client net HTTP client transport of type init failing transport doesn't support cancel request timeout not supported. So transport's one of those things of the client deal in there, and I wonder if it says anything here. We got some info stuff. So minions, fave icon, and requesting post, API Stripe, charges, request to Stripe failed, net HTTP client transport. So that's where it bombed. So how do we fix that? Charge params. So here we're doing go for it. You want to explain it?
No.
Because we're on App Engine, use a custom HTTP client. This is being set globally. However, if we wanted to do it this way, we'd have to use a lock. And you can watch the video where Caleb describes that. I put that right there. And so this is like step one, and then we're going to add in idempotent, which means that you can only charge once. And so, like, if the button gets clicked twice, or if they submit, and then right when they're submitting, their computer crashes, and then they go back, they're like, did I actually buy it or not? And they submit again, right? It only allows you to, okay, this transaction is only going to be processed once, as opposed to we accidentally charged the customer 8 times on that because they just kept hitting their submit button, right? So that adds in idempotent. I don't know how you say that.
It's a mathematical term.
How do you say it? How?
I think it's idempotent.
Idempotent. I think you're right. And then here's the complete version there. So we'll kind of step up to that. This will actually work, but
It's not good for parallel.
yeah, it's if you have multiple people hitting your server at once, then I guess this will create issues. So we get a client, and when we get a client, that gives us back HTTP client. And what is an HTTP client? It is a struct with some of these different fields here. Check, redirect, transport, jar, timeout. So here's this transport thing. Specifies the mechanism by which an individual HTTP requests are made if nil default transport is used. I don't know, so you could dig into that further, but transport is, I guess, how things are getting transported, right? Like, here's for the client.
Yeah, the client thing wraps around the HTTP transport. The transport is actually what's sending the signal out to the other destination and getting stuff back. And then, it's just an interface, just has the round trip thing. You give the request, gives you back your response. So the client wraps around that, things like get and post methods, as well as letting you set like things like a timeout for how long you want to wait for a response and all that, and other things.
That's cool. So we have let's go back to, here we've got a client, right? URL fetch, get a client. And then if we have a client's got a transport, which is of type round tripper. And round tripper is an interface which implements the round trip method, right? It has the round trip method. So that means that client is implementing the round tripper. And so does client somewhere have this method? It must, right? Is that right? Or because
No,
it's
client's not not implementing it. It's got something that implements it in it. Oh no, it is.
wouldn't client have because client transport round trip? I'm not sure how
Yeah,
if you
it's-
just
it's
say,
got
hey,
it.
I'm embedding an interface in my embedding an interface in my struct because
No,
normally for a type
It's not embedding an interface in its struct. It's just putting it's got a member variable that's of type round tripper.
a member variable of type round tripper. Member variable of type round tripper. Huh. So would client be implementing the round
client-
tripper interface?
Round tripper?
So
Round tripper?
Yeah, so inside of that struct, there's an item transport that has this function. So it is a round tripper,
so client is not though, but
Right.
transport is.
yes.
Okay, cool. So transport would have this function right here. Got it. All right.
So that's what
okay.
URL fetch is doing is normal round tripper just grabbing the TCP connection and sending it. URL fetch will send it. Will grab the TCP connection to Google's US server and wrap around it the extra parameters it needs for Google to then forward it to somewhere else and send it back to your app engine.
Interesting. So then we do a Stripe set HTTP client, and we pass it the client, HTTP client, and then we do the charge params, and then we set the source, give it that, and then do a new charge with the charge params, and all that. So
So I believe there's a way somewhere in the Stripe docs that lets you set the client on a per transaction basis, but not being shown here. So we're setting the
it'll be seen right down here at the bottom. You're the one who
It is.
figured that out at Bootcamp. Yeah, you want to see it again, just so you can start pulling that up from memory? It's right here, backend config.
That's right. I remember now.
So let's just see that. What are you waiting to see? Could go up one. Thank you for the money, sucker. So there's a little bit of magic in there because we're relying on a lot of other stuff already being written for us.
So does that show up on your Stripe console, or is it not until the next one?
No, yeah, I think it does. Let's go look at that. Refresh. $400,000. At this rate, I'm quitting my job this afternoon.
Hey,
It makes me a little happy, even though it's just fake. It's weird. Charging, and so now let's look at impotent. I'm going to call it impotent because it just looks like that to me.
it's impotent.
And so here.
That is kind of right. It only has one charge, so. Okay.
So we're just creating a UUID, and then charge params is a independent whatever key. How do you say it, Jenny? Idempotent has an idempotent key, and charge params, if we look at that again, is here. And what the heck, man? So charge params has an idempotency key, and I'm looking here and I'm not seeing idempotency key. So where do I find the idempotency? It's charge params. Anybody have any thoughts on that? What am I missing?
It's in params. You're embedding
Oh.
another struct in there.
We're embedding in our struct. There it is. Thank you. Perfect. There it is. So that's kind of cool. Does anybody have any questions about that? That's embedding another struct. Good. Okay. So we get the charge params idempotency key, and we just set that right there. And so that'll only let it set once. We don't need to watch that, but same deal. And then it prints out the key.
That
so you
ID
can see
is, by
that.
the way, a UUID.
Yeah, right there. We could almost just, no, because it returns multiple returns. Never mind. And then here's the complete version. So the complete version, and why don't you talk about this? Because you're the one who figured it out.
If I can
Why?
remember.
Because we're on App Engine, we use a custom HTTP client. And so Stripe has, so this is from the package Stripe right here. And it has backend configuration. And if we look at backend configuration, it's a struct, and it takes type, URL, HTTP client. Backend configuration is the internal implementation for making HTTP calls to Stripe. And if you look at the documentation on Stripe, and so let's go look at that, godoc.org, and we're just going to look for Stripe here, and Stripe Go, and then in here I'm just going to do Control F and Engine, and so here we have set HTTP client overrides default HTTP client. This is useful if you're running in Google App Engine, an environment where the HTTP default client is not available. So that's kind of interesting. That's like one of the things I remember from the training. But set HTTP client, we use that somewhere, don't we? Would that be
Not
over
there.
here?
Yeah, that would be back in the older code. That would be, so not in this complete code anymore though.
All right. So where do we find? Let's go back and look at the.
So you're configuring the backend configuration. You're telling it, hey, we want to go to the Stripe API backend. We give it the Stripe's API URL, and then and then we give it our URL fetch client, which the URL fetch client changes on every call because you got a different context for every call. So, which is why the global one back before was bad, because it was setting it globally to a URL fetch that had a context for one URL connection, which is not good overall.
All right. So explain that all again. Why would I need to use backend configuration? Because part of it is like the reason.
So backend configuration is just a plain struct, but then that's a if you go into the code again, that struct B there is a parameter down here at charge client. So once you create your charge parameters like that before, you give the key, the idempotency key, give it your token, and then you create a charge client, which includes the backend configuration stuff. And then instead of just saying Stripe or instead of just saying charge.new now, you say charge client.new. Which will use which will be just for your request having the URL fetch, so you don't have to worry about a global effect.
Okay, because before we were doing charge, and now we're doing charge client.
So just plain charge.new is actually probably using like a default charge client, similar to how just plain HTTP GET is using a default client there.
Takes backend. All right, interesting. So a few nuances there to wrap your head around. But anyhow, this is apparently the code that works really well.
So with this, each request is using a URL fetch that's using the correct context for that request. So you don't have to worry about a global effect. So that means it can be fully parallel as needed.
Because that's where we're putting in the fetch right there.
Yes.
As opposed to before, it's just like wide out in the open.
Yeah.
And this is a little bit contained. All right. So, I don't know.
So this is also using the exponential backoff algorithm.
Oh, exponential backoff. Yeah, there's a couple interesting things here. So we do Stripe backend configuration, and that's a struct, and we do the Stripe API backend, and then the URL. We can just see what those are there. The type, URL, HTTP client, supported backend, URL to go to, and then HTTP client. So we get that, and it gives us backend configuration. We get a new UUID for our idempotency, and then we do a loop here. And that loop takes us all the way there, right? Yeah, for loop. And so it's always going to be running. Why would we always want this running? Because if a charge fails, then right here we could check that failure, and maybe as a network error, and we could retry it. And And so in that for loop, we do Stripe charge params, and we build our little charge param struct here and put in the fields. And then we do our idempotency key, add that to charge params, and then we do set source and Stripe token, right? So that's where we're kind of passing that token. So we're going to pass all this over to Stripe. And then we do charge client, charge.client, and this is just a variable we created, right? So we were kind of distinguishing that
Yep,
before.
it's another struct.
But with charge client could take a Stripe backend and a key. Let's compare that just briefly here to, like here we were doing, we called it
You just had charge new.
charge new, but here we're calling it charge client new, right? And here we called it charge new, but where did
Charge there came from.
charge there came from up there? That's interesting. So charge and then just that package, but this time we have charge client, and I guess on client there's a method new, right? So
Yes.
somewhere on client there's a method new. And is this attached to client? And that's just right out of the documentation. So if we go look at the documentation on that, then we're going to have a charge, and that will just sort of be at the top level, I'm guessing.
It's another level down. We're in stripe-go. It's stripe-go/charge.
How's it? Charge. Find charge.
So it's got a new function there and a client type.
Right there, that one.
Yep, that's.
Oh, okay. So package charge new, and then we also have client, and we have new right there. And if we do the new right here, it gives us back a Stripe charge and an error. If we do the client, it gives us back a Stripe charge and an error.
That Stripe charge that it gives you back, you probably want to store in your data store somewhere, because that's the information about the thing, like an ID numbers and such, which may be helpful if the client cancels the charge on their credit card website. You're going to want that information so you can talk to the credit card people and figure out how you're getting the money back.
Interesting. So, get rid of 05 there. So we get charge client new, charge params. We get back a CH. And that's just for our info. So that would be that thing that you'd want to store so you can track old transactions.
Mm-hmm.
And then if there's an error and the error's not nil, then we're going to check again, is it a network error? And so here's assertion. And assertion is for something which is of an interface type, right? And so we're asserting that this is a net error. What kind of error? It's a net error. And if that's true, right, if that assertion's okay, then we have the net error and we have that's okay. So we can check, hey, is that okay? Like meaning was net error and the net error is temporary? Well, if it's a temporary network error, then let's just wait a second and go back and try it all again. And so that's what that does. Otherwise, return error, right, if it wasn't a temporary network error.
So you definitely want your idempotency key here too, because that temporary network error may just be a timeout and it took a long time to get there. So the idempotency key will mean that even if you send that, if you sent it twice and it had just been a timeout error, you won't accidentally charge twice.
And I think I should show you that these keys here, well, when you're in the documentation and they give you the examples, they'll give you the keys in the example. That just gets built right in. So that's customized for you. That's your key.
Yeah, when you log in, it gives you your personal key in the docs.
But you could also go to your account and account settings, and then this is just my junk account, so I'll never use this for anything real. But here's the API keys where you can see your production keys that you put in there, not just your test keys. So that's where you get your keys. So that's the Stripe page, and then the rest here is handling the payment, right? Just seeing if there's anything new that has changed here, and that all looks the same. Thank you for the money, sucker. So that's kind of cool. What are your guys' thoughts on that? None? No thoughts? Empty thoughts? You've achieved Buddhistic emptiness? I think it's pretty neat and pretty powerful to be able to set that up. It's not that bad, and
It's relatively simple.
there's a couple of gotchas to watch out for, and definitely some more things to look at in the documentation and read through. But there's your basic working example. All right. Nobody has anything else?